Warm welcome up on stage to Cloud and AI Director at Microsoft, Adir Ron.
Yeah.
I know you are very excited to talk to the audience,
Definitely.
so I will just release you into it. Say.
Hi, everyone. Good afternoon. My name is Adir Ron. I'm the EMEA Cloud and AI Director from Microsoft. I'm here to spend the next 25 minutes talking to you about what do we see for AI but beyond the hype. I know many of you are looking at AI and thinking about the models that are being released every week, about some of the innovations around tokens and capabilities like MCP or RAG. But I think if we're trying to assess the real potential, that's probably not lies in what is the most recent model. It's some of the potential of AI transformation that we're seeing beyond. So we'll try to talk beyond just the hype and some of those buzzwords that we keep hearing into what are we seeing as the actual opportunity, challenges, and learnings that we can do from AI transformation. So I think the biggest thing you can see around AI is that this is still in the making. Okay, this is just some of the scaling laws that you can see for AI. They are unprecedented. We're definitely flying the plane while we're building it. So everything that you feel like is happening in a massive pace, we're still not there. We still have ways to go, and even while I'm talking to you right now, in about a week or two, there's got to be a newer model, new capability, new things that everybody would be talking about, and that is a very hard way to build strategy around. That is a really hard way to differentiate between the noise and the capabilities. So us in Microsoft, we're trying to assess what is the best way to kind of understand this mechanism, this whole transformation in a larger context. And I think the best way to do this is to try and assess where have we started, what are some of the large progression points plus challenges we've seen, and where are we headed with this? And then this would allow us to maybe elevate the discussion beyond just the hype and that plane being built while it's flying into something that is materially meaningful for us. So let's talk about the role for artificial general intelligence. This is where we're trying to get. We're trying to build that super intelligence that would be able to reason, to make decisions in a very articulate way, to represent us and represent our enterprises and represent our customers, and really transform how AI is materializing the world. How do we see this as another actor, as another super intelligence that we're working with? This is a dream. We're not there yet, but even making those strides to that dream allows us to do a lot with AI. So we all started in November 2022. Anybody ever guesses what happened back then? A bit of a product that was launched. Microsoft is a big investor. So that was ChatGPT. That was the ChatGPT moment. A little, just 2 years, which is just 3 years, which is quite amazing to think about the amount of progression that we've seen. This was actually just a chatbot. That chatbot was based on something we're calling language model, which is, if I'm really trying to dumb it down, a way to predict the next word. It's like autocomplete on steroids. It has a model, it takes all of the context and tries to guess the next word out of that context. And while it was trained on a lot of data that was representative of human thinking, human reasoning, documents, that actually articulated some of the common knowledge that we have. So that model was not just predicting language, it was also predicting how we think, because most of the language that they use is actually being used for us to describe how we think. So that was a bit of a, I don't know if even back then, OpenAI, definitely not Microsoft, really understood that building a model that can really autocomplete what is the next sentence based on so much data would allow us to start exploring how thinking, or real thinking, AI, artificial thinking, is happening. Back in March 2023, that was the GPT-4 moment. This was the first time we tried to move beyond just the language model into something that can take the capabilities of a language model, but also connect data into that. And that created the AI Copilot. So you can see just behind me, there's the universal interface, which is the language model, so we can interact with it as I'm interacting with you It would understand my intent as you understand my intent as well. But once we added memory and context into that, we can now have it understand what we're trying to do with specific capabilities, with specific data points, and then make reason around them. So, up until now, sounds really cool, but already in this point, before even talking about agents, autonomous, physical AI, and things like that, we're facing a lot of challenges. If we're thinking about AI right now, most of the AI co-pilots that I'm seeing right now across the boards fail. And they're not failing because of the model. Many people I'm discussing are saying, hey, if I'm just gonna switch to GPT-5 or wait for GPT-6 or whatever, then this model will be perfect and we will have a great assistant. That's usually not the problem. The problem is around data. The data that we were building for so many years is meant for execution. It's transactional. We use this to make some decisions. We used it to save some data that represents an application. It was never meant for understanding, for someone to read this data and understand the context behind it. And while we cannot mitigate that, our AI co-pilots and potentially would unlock anything that comes afterwards, agents, physical AI, would fail. By a recent survey by Gartner, by 2026, 60% of the AI projects will be abandoned just because of lack of AI-ready data. So it's not about the model at all. It doesn't really matter what is the model or what happens in the AI world. If your data cannot understand or digest what it does, if you're not talking with AI in the language that it understands, you would never be able not just to hack assistants, but also anything that you want to build on top of it. Autonomous assistants, agents, and etc. I want to give you some examples of some of the places or ways that we're trying to mitigate that, taking data that was mostly transactional, that was not based or nobody thought about this data being used by AI, and trying to mitigate it, transform it in something that AI can definitely understand. The key component is something we're calling Fabric. You may have used it in the past. As many of the products from Microsoft, this was not an intended product for AI. We're now reimagining the whole company and all of our products to be not just human-friendly and data-friendly, but also AI-friendly. So you can see here an example of that custom analyst. What we're trying to do here is to pick some of those data sources and try to transform them from an executional standpoint to a language understanding and semantic model standpoint. So there needs to be a layer, and we're building now this layer slowly with a lot of our customers and with some protocols like MCP, for example, to try and generate a data layer that has some conscious and understanding baked into it. And again, if you're thinking about most of the databases in the world, they were not built like that. Think about any data scheme that you ever saw from a data scientist. None of it is self-explanatory. If you just let an AI or yourself read it, you wouldn't understand anything on top of it, not the connections, not the relationships, not even the intent of the data itself. So in a sense, one of our key challenges right now, beyond all of the hype that we're seeing around the models, is go back to the data storage and try to make sure that that data is AI-friendly, that that data can be easily translated into something that AI can make sense of. And the way that you know that you achieve this is when AI can start answering questions that are transactional. Because as we thought about this, AI is mostly today language models, so it can really answer things that are based on text. But if you're starting to talk about core data, this is where we see most of the challenges. You can see here an example of an agent. That agent is based on that same Fabric data, which is the transactional data. So it can definitely generate the answers from that SQL query, from that MongoDB query, from the NoSQL query, and try to bring it as context to something that it can understand and make choices upon. Again, this is not trivial. It seems trivial to us because we're thinking about data in a very transactional way. But language model is based on language. And making that conversion between our old data sets into something that can really make sense for AI requires a lot of investment. Another core component of AI is that most of the traditional applications are stored in silos. So we have this data set that represents our email, this is for identity, this is for our contact center, this is for our application. So we're thinking about things very transactional and very siloed. Most of the data in AI that the language models understand are actually graph-based. They're vector-based. So they don't understand data very well without trying to build context and graphs around it. So in our challenge to make our databases more AI-friendly, to unlock anything that comes after, one of the key challenges, again, a good example for Fabric, is to try and describe that data as a graph. So you can see here an example. We're trying to assess from that graph's perspective everything that a person either posted on social media or saw on social media. We're trying to tag that data and then build something that would not be a relational, neither a NoSQL answer, but actually would be a graph answer, something that would allow AI to use their vector capabilities to talk in that same language. So I know a lot of those things that we're talking right now are definitely not the hype areas of this model or that cool model. This is the basis. But I can tell you after 3 years that we've been doing this with Microsoft, if we're not hacking this, you have no chance of succeeding with AI. And sometimes the core idea is to go to that areas that are considered to be our data estate and try to bring this together into that new model of AI. And some of those tools might be your starting point, even before talking about what kind of model are you exploring. You can see behind me, this is how graph looks like. So when we're thinking about all of those connections, this is a data set that AI can definitely understand better. So we try to hack this. We understand how to create a data context that can really resonate with language models. We're now at a point that started off with GPT-01, when language models actually becomes reasoning models as well. So they're not just making sense of something that is language-based, but also can bring some data science and statistics around it. GPT-5 is a good example of this. You can see here there's the traditional language models that are based on understanding and mimicking language, but we're already starting to see some of the research capabilities, which are part of O3, O4 Mini, and some of that series, which can actually mimic and understand intent. They can think about the data before making a decision. Everything that you see here on the slide is pending what we just discussed, having good data that AI can understand. Otherwise, language or reasoning would not work. But once you have it, you can unlock both of those capabilities. I like to show a good example. A lot of people don't understand because GPT-5 contains both language and reasoning. So what is the difference? Let's make it interactive. So you can see here, I'm asking GPT-4, I'm asking a very basic question. So Kate's mom has 5 children, la 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 Lulu. What would be the last one? Any guesses? It's already in the slide. Lulu, right? That makes sense because we're looking at the names and we're saying, okay, so if we have la 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 Lili and Lolo, then Lulu makes sense from a language perspective. Anyone knows what's the real answer if you were a reasoning model? Kate, obviously. So this is exactly the difference between trying to mimic language and bringing reasoning into it. It's a very basic example, but it shows you how those models are thinking differently on that same problem. And sometimes when something makes sense from a linguistic perspective and would really easily get the LLM to hallucinate, if you're thinking about this with a reasoning model, there's a better chance for you to get to a real answer. And that takes us into number 4, which is agents. So GPT-5 actually is enabling that agent era, which means that we are now trusting AI enough, if it has the right data set, to generate actions by itself. And that is also quite interesting to try and understand, because now we have the universal interface. We talked about having the right memory and context from a data perspective. We now have the capability to do reasoning and planning as well. You would think that all of it is enough to create something that is thinking, understanding data, and then acting upon it. But we still see that the spectrum for reasoning is quite large. So we do have some that drives minimal operational excellence, It's like small things that we can automate quickly. And then there's the large capabilities that can really transform human and non-human collaboration. So instead of talking about agents, which I know a lot of you are doing already, I'm going to talk to you about the 3 types of agents that we're working with. Every one of those agents require different perspective into working with. The first one is the task-based agents. So if we're looking at this, up until now, we talked about the front end, you discussing with the model, getting some answers from that data sets, understanding what the model makes sense of. Now we're actually trying to move to the back end. We don't care about the interaction piece of it. We don't care about you interacting with it. We want it to do something by its own. While this is considered to be the small change, it actually, we're thinking 40% of the enterprise will have task-based or task-specific agents by 2026, which is up from 5% today. So even though it, for some people, seems to be like it's not the most interesting, we're looking for that agent that can understand, do a lot of those cool things together. That actually is something that you can win very quickly. In Microsoft, we're trying to assess agents with something you probably are familiar with, is the ROI spectrum. One is, obviously the return here is a little bit lower because it's just doing one task, but the investment in generating an agent that does this is also quite low. So in our spectrum, that makes sense to invest in even task-based ones because it's very, very easy to educate them to do this. And if we're doing enough tasks, we're getting into significant ROI. Let's look at the same agent that we've used previously. Again, as I mentioned, everything is based on you having the right amount of data. This is a very specific autonomous agent, which is based on a task. I'm getting this quote. I'm doing some very pre-checking that is not considered to be massive reasoning, and then I'm doing something at the end of it. Okay, that could replace a task that a human is doing today with something that is fully autonomous. As we've seen with Gartner, we're seeing a spike in those areas where we're taking tasks that are highly repetitive and we're trying to move them. As I promised you, the investment part here is quite low as well. You can see how I defined this agent. We didn't have to do basically anything but connect the data into it. So for example, this is the field agent. What we're doing is trying to assess the triggers. What is actually triggering this agent? What are we listening to? 2, what is the knowledge base? You've seen Fabric as a good example. There's other knowledge bases that are at the disposal of this agent. And then 3, what are the functions or the activities that that agent is doing? All of that today is defined by vibe coding and low code. So very little investment to take a task-based agent, potentially the easiest starting point, the low-hanging fruit of all agents, and try to mimic them or understand what kind of those activities or tasks could be autonomous very quickly. And you can see here all the way to actual descriptive. This is really cool if you have someone in your domain that can articulate a small task, even in plain English. That should be enough for that agent to work extremely well if it's highly repetitive. The second one, 4.2, and as I mentioned, we're trying to differentiate between agents, is what we call the AI worker agent. The AI worker agent is a little bit more complicated because it now looks not just as one task, but is trying to reason between agents. So it has a lot of tasks in disposal, but we can build like a super agent that orchestrates between them. I do have to say, and again, we're trying to give you a lot from our experience, it's very hard to go with AI worker without having task-based agents before. Because in most cases, you don't want to build a lot of logic into that agent. You want to have it orchestrate many people. Think about any org chart that you're familiar with. There's some people, everybody can do something, but then at some point, you don't want a person that can do all of their jobs, but someone that can orchestrate. That is called a manager. In the same way, you would not put a manager without employees, or you would not put too many employees without an orchestrator. Same thing happens when we're thinking about agents. It's not very different than thinking about how to build a humans or human-related one. This is why AI agents are not easy. 93% of the agents that we're talking, it's almost 100%, is failing right now because they're not doing this in the right trajectory. They didn't build the right data estate. They haven't built enough of those task-based agents that could be utilized. We see a lot of them just fail because meeting some of the complexity needs. So obviously, return here is amazing. You can definitely replace a lot of different tasks all the way to even automating a key part of the business, but the investment is also high. There's a lot here that needs to be done to make sure that we're orchestrating this in the right way. I wanted to give you some things in terms of what is our top considerations today when we're trying to build that AI worker. And I think those are the 3 questions we at Microsoft are asking every AI worker that we're trying to build. What is the smooth collaboration around your apps and agents? So again, if this is a manager, who are we managing? What kind of tasks do we want it to achieve? As you go up the chain, that would have more employees at his disposal and can mitigate them in different way. And then thinking about designing, deploying, and definitely thinking about governance here. Again, with the manager example, if you're taking a manager, you have to make sure that that manager works with the compliance and governance that is quite different than a task-based one. And then last, how do we manage and optimize them? Because they also need to learn from that experience. Satya, our CEO, is actually talking about this moving from the AI excitement phase into the AI at scale phase. And if you're answering both of those questions, all 3 questions, you're in a good place to start doing this. A few examples on how we do this today. So if you're trying to build that agent factory, you need to focus on models, knowledge, trust and security, and then focus also on the orchestration and observability to make sure that you're continuously learning. Let's give a quick example. I don't have a lot of time to go into that. This is quite a complicated topic, but maybe just something that would give you some touch points on what we can do here. So for example, on the model side, one of the things that we understood is one size does not fit all. This is just all of the models that were released in the last 18 months. There's a lot. And we don't think there's going to be a clear winner. Again, as any other manager would tell you, it would be different between models. So just in Foundry in Azure today, we have more than 1,100 frontier models, including from OpenAI all the way to the open source ones. What we're trying to introduce right now is actually having a task-based agent that allows us to choose the right model for our task. You're now seeing the model router. We've actually implemented it as part of GPT-5. This is why you don't see a lot of different GPT-5, but only ones. And that allows us to explore the prompt and then choose the best model that can help that prompt, not just from accuracy perspective, also from cost perspective. If I can get there with a bicycle, I don't want to buy a Tesla. So we're trying to also think about FinOps as something that we're introducing here. That model, as you can see, can pick and choose from different and various understanding. And this is a great example how an AI agent is actually using another AI agent to make sense of what kind of model he would use. And again, breaking the problem of the AI worker into small task-based agents and then trying to start integrating them across the board is a sure way for success. Let's see again the orchestration piece. This is where you can see some of those flows. That could be a multi-agent workflow that are talking between one another, or connected agents as well. All have their share of knowledge, what they know, and actions, what they can do. And again, if you're thinking about breaking this in the lower domain and then going up the scale, this is a really great way to get into that AI worker side. Let's see some examples here. This is, again, part of Foundry. You can see here different types of agents. We haven't tried to put everything in the mind of one big agent. That potentially would come later, but not now. And then you can see here that one of the things that we're introducing is for every agent, the ability to operate other agents as well. And then there's much more governance and understanding of how that full-blown process is happening when you're trying to break it into different workers and different processes as well. This also really helps with trying to assess some of the observability around it. So that means what kind of models are we using? What is the size of them? What is the accuracy? What is the latency? Trying to, again, assess, are we using the best worker per task? The third and last one that we're also exploring today, it's still task-based, but or AI worker, but it's now part of the physical AI. Now when we're trying to reason, we're actually trying to
explore physical AI as well. You can see here one of the startups that we're investing with OpenAI. It's called Figure. I think this is a good example to try and understand how that is working. Let me just quickly show you this. So, sorry about that. Okay, so you can see here, and hopefully we can also. Let me see if I can click on it. If not, then I'll let you explore this later. This is how Figure is looking right today. Figure is actually based on all of the multi-model capabilities, so it reads and understands both text, but also streaming as well. And it can start mitigating small tasks. Now, obviously, the small tasks that we're starting off with is folding laundry, doing the dishes, taking the dog out, and things like that. And we're slowly and gradually trying to build it into an AI worker by educating it on how to do different things. This is, I think, the first iteration that is actually working for physical AI. We're definitely going to see more of those coming up as we go to that agent mode. So I know many of you are thinking agents, they're thinking virtual agents, but we're actually now thinking about physical agents as well with the same concept, having strong grounding around data, understanding task-based autonomous capabilities, and then trying to package all of those task-based autonomous capabilities into something that makes sense. So you can see here the charging point, and then in this case, Figure will just go maybe wash the home or try to do anything. And again, everything here is task-based capabilities that we've educated. How do you water the plants? How do you walk the dog? How do you do the dishes and stuff like that? So again, task-based becomes an AI worker. I'm going to finish now because I think I'm already at time, but also to talk a little bit about the future. Where are we headed from here? So we're currently at number 4, which are agents. And as you can see, we talked about task-based AI worker and physical agents. We're actually now already starting to see some early research around something we call innovators. Innovators are able to research or reason without us grounding them in anything. They're great for research. Some of the early exploration of Microsoft Discovery and OpenAI, what we're doing is to try and research new ideas and new capability around chemistry, healthcare, and some of those areas. So that means we're not actually instructing it to achieve something, we're actually letting it think by itself. So it's reasoning not around the solution, but also reasoning around the problem. And that can help us see things that us as humans couldn't see up until now. Even with AI, up until this point, we're always guiding them into what we're trying to fix. And then lastly would be the innovator side, is the organization side. So what happens if you have a team of innovators and a team of agents working together, and you can go up the chain all the way to the CEO level? And then you can have a full organization that is based on thinkers and agents that can operate all the way into those autonomous tasks. So when I talked to you, we were kind of looking at some examples of which are mid-level management that can do some of the task-based orchestration. As we go up the chain, that would become more and more complex up until a point that we'll have an organization that will be fully AI, and that's definitely where we're trying to aspire into. How long would it take? Sam Altman, which is someone I'm trusting in many of the things he said it would take 5 years, give or take. We're already about a year and a half after he said that. So you can calculate in the pace, and if we talked about the plane from, we're flying it while we're building it, where are we trying to get into? And again, if we're making the steps in the right order, if we're trying to, avoid the hype and understand the capabilities around data, grounding, task-based agents, and all of those learnings, this will set you in the right pace to making sure that you're meeting those innovators and those organizations when they arrive. Thank you so much.
Thank you so much. Just before you leave the stage, so does this mean that we will have companies run by one person and just AI agents?
Yes, we already have today. If we're looking even at Microsoft, there are some places in the business which are autonomously managed today. The place that we're lacking today is places where we need innovation. So if This is just autonomous, no thinking, just reasoning around tasks that could be done today. If that requires some level of creativity, we're potentially looking at the GPT-6s plus. So we're still not there yet, but it's definitely part of the research. Some of the new models that we've been exploring, like for finding new cures for drugs and chemistry, are already exploring those innovators. So they're trying to think different than humans and get to potentially different outcomes.
Yeah. Okay, so I have another question. I know we're a bit over time, but I have to ask, because in the film, when we invited into this, I said, like, I want someone to fix that AI can go out walking with my dog in the middle of the night in the rain. I just saw the figure.
Oh, it works.
Figure 03. So in what period of time can I buy it?
So it's potentially very close into mass production. I can also share with you that we're exploring the price point, which will be as a car, more or less. So it's not going to be something that is outside of the reach for many people.
Do we talk about a cheap car or an expensive car?
I'm guessing once that comes, that will be a lot of options for it. But if you're thinking about it today, physical AI is basically a lot of multi-model capabilities.
Yeah.
And then at the end of it, some things that can do functions, but only in a physical space. It's not a very common or different thing than the task-based agents that we see from a virtual perspective on the thinking side. And most of the mundane things like walking your dog or doing the laundry are task-based.
Yeah.
So they're quite repetitive. Not a lot of thinking around that. It's just someone that can reason through that process. So this is why we're thinking this is a low-hanging fruit. I haven't called it the future. I'm calling it right now, because I think in the next 12 months, we will see some major players go into this and scale on physical AI. I'm definitely going to buy one when it's available.
Yeah, it both fills me with joy, and I get a bit scared at the same time, but mostly joy. Ladies and gentlemen, please give him a big hand. Thank you so much for coming here today. Thank you, sir.